Bismillahirrahmanirrahim. Chapter 2 Differentiation, Exercise 2.4, Question number 5. We have to differentiate x square minus 1 by x square with respect to x4. So let y equals to x square minus 1 by x square, and we differentiate both sides with respect to x. We put a d by dx here and a d by dx here. And now to take this derivative, we are going to adjust this shape. We are going to write it as x to the power minus 2. It will help us to take the derivative with the help of power formula. It will be much easier to take the derivative in this way. Now I apply the power formula. Derivative of x square becomes 2x, and the derivative of this minus remain as it is, and the derivative of x to the power minus 2 becomes minus 2x to the power minus 2 minus 1, that is minus 3. Now you can adjust this minus becomes plus, and we get 2x plus 2 divided by x cubed. This x to the power minus 3 can be written as 2 divided by x cubed. Now you can take the LCM, and the result is 2x4 plus 2 divided by x cubed. You can see we can take a 2 common. So dy by dx becomes 2 into x plus 4, x to the power 4 plus 1 divided by x cubed. And now let t equals to x to the power 4. We name this equals to t. Differentiate both sides with respect to x. So we get d by dx of t equals to d by dx of x to the power 4. So I get t by dx equals to 4x cubed. Now I am going to take its reciprocal. So I get dx by dt is equal to 1 by 4x cubed. Take reciprocal on both the sides. And using the chain rule, dy by dt equals to dy by dx into dx by dt, and the result is dy by dt is equal to, just put in these the values of dy by dx and dx by dt. We get 2 into x4 plus 1 by x cube into 1 by 4x cube. 2 got cancelled with this 4, and I am left with x4 plus 1 by x cube into 2x cube, and the final answer is x cube dy by dt equals to x4 plus 1 divided by 2x6. Now we have to differentiate part 2, differentiate 1 plus x square to power n with respect to x square. So let take y equals to 1 plus x square to power n. We differentiate both sides with respect to x, and we get dy by dx is equal to 1 plus x square whole to power n, its derivative. We will use the power formula, n into 1 plus x square to power minus 1, and then chain rule it. So we get d into d by dx 1 plus x square. We apply the chain rule here. N 1 plus x square to power n minus 1 into d by dx of 1 plus x square. So derivative of 1 is 0 and the derivative of x square is 2x. So you we get n 1 plus x square to power n minus 1 into 0 plus 2x. So the final result is 2nx into 1 plus x square to power n minus 1. Now let t equals to x square. We differentiate both sides with respect to x, and we get dt by dx is equal to 2x. Take its reciprocal, and we get dx by dt is equal to 1 by 2. And now we are going to apply the chain rule. Dy by dt equals to dy by dx into dx by dt. So just put in the values of dy by dx and dx by dt. Here are the values. We can cancel 2 and x, and our final answer is n into 1 plus x square to power n minus 1. Part 3. We have to differentiate. Part 3. We have to differentiate x square plus 1 by x square minus 1 with respect to x minus 1 by x plus 1. So let y equals to x square plus 1 by x square minus 1, and we are going to differentiate both sides with respect to x. So we get d by dx on both sides. Here we will get dy by dx, and here we have to apply the quotient rule. So quotient rule is denominator square, denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. So derivative of d by dx of x square plus 1 becomes 2x plus 0, and here it becomes 2x minus 0. Just put in the derivatives, and now 2x plus 0 can be written 2x. It can also be written 2x. And now open up all the brackets, and you get 2x cube minus 2x minus 2x cube minus 2x cube got cancelled, and our answer is dy by dx is equal to minus 4x divided by x square minus 1 whole square. Now we will put this thing equals to t. Let t equals to x minus 1 divided by x plus 1. Differentiate both sides with respect to x, d by dx here, d by dx here. This becomes dt by dx, and here we have to use the quotient rule again. So x plus 1 square in the denominator, x plus 1 here, derivative of x minus 1 minus x minus 1 here, derivative of x plus 1, derivative of x is 0 and the derivative of x is 1 and derivative of 1 is 0. Derivative of x is 1 and derivative of 1 is 0. So we get this thing. And now 1 minus 0 is 1, 1 plus 0 is 1. So I get this. Open up all the brackets. You can see x got cancelled and I'm left with dt by dx is equal to 2 divided by x plus 1 whole square. Take its reciprocal and evaluate dx by dt equals to x plus 1 square by 2. Now what you will do using chain rule, dy by dt equals to dy by dx into dx by dt. Put in the values of dy by dx, put in the value of dx by dt. You get minus 4 by x square minus 1 whole square into x plus 1 whole square by 2. Cancel whatever you can cancel. I see this 2 can be cancelled, and also this x square minus 1 can be written as x plus 1 into x minus 1, and we have a whole square here. Now split up this and you get x plus 1 square, x minus 1 square. And in the numerator we have minus 2x into x plus 1 square. You can see this got cancelled and I am left with dy by dt is equal to minus 2x by x minus 1 square, and which is the answer. Part 4. Part 4, we have to differentiate ax plus b by cx plus d with respect to ax square plus b by cx square plus ax square plus d. So here let y equals to ax plus b by cx plus d. Differentiate both sides with respect to x. You will have to use the quotient rule here, d by dx here, d by dx here. This becomes dy by dx, and here we apply the quotient rule. Cx plus d whole square, cx plus d constant, derivative of ax plus b, which will be a minus 0 and a plus 0. And finally you can make this correction. This must be a plus 0, and then it will become a, and minus ax plus b into d by dx of cx plus d. So it becomes c plus 0 divided by cx plus d whole square. So what do we get? Cx plus d into a minus ax plus b into c. The final result becomes, open up after opening the brackets, this acx got cancelled and I have got ad minus bc divided by cx plus d whole square. Now let t equals to ax square plus b divided by ax square plus d. Differentiate both sides with respect to x. Dx by dt, we get dt by dx on this side. On this side we have to take the derivative with the help of quotient rule. So we apply the quotient rule here. Ax square plus d plus d whole square, ax square plus d constant, ax square derivative of ax square plus b minus ax square plus b constant into derivative of ax square plus d. So we just apply the derivatives. A is constant, derivative of x square is 2x, so the derivative of ax square becomes 2ax. Also the b is constant, so its derivative becomes 0. Derivative of ax square becomes 2ax, and d is constant, so its derivative becomes 0. So now I'm going to write it as 2ax. I will write this also as 2ax, and then I will open up the brackets. Instead of opening up the brackets, this time I am taking this 2ax common, and inside the bracket I have ax square plus d minus ax square minus b. So you can see this ax square got cancelled and I am left with 2ax into d minus b divided by ax square plus d whole square. Now take its reciprocal to get the value of dx by dt, which becomes ax square plus d whole square divided by 2ax into d minus b. Now write the chain rule, dy by dt equals to dy by dx into dx by dt. Put in the values. The value of dy by dx was ad minus bc over cx plus d whole square, and the value of dx by dt was ax square plus d whole square divided by 2ax into d minus b. No simplification can be seen, so we are just going to rearrange the values and write them as one fraction, and we get the result dy by dt equals to ad minus bc into ax square plus d whole square divided by 2ax into d minus b cx plus d whole square. Let's get to part 5. Part 5 is we have to differentiate x square plus 1 by x square minus 1 with respect to x cube. We will take this as y. So let y equals to this, differentiate both sides with respect to x. So you put d by dx here, d by dx here, and apply this becomes dy by dx, apply the quotient rule here. So we get dy by dx is equal to x square minus 1 whole square here, x square minus 1 constant, d by dx of x square plus 1 minus x square plus 1 as it is into d by dx of x square minus 1. Derivative of x square is 2x, of 1 is 0, of x square is 2x, of 1 is 0. You can see it here. Now let's write 2x plus 0 as 2x, 2x minus 0 as 2x, and now open up these brackets and you can see 2x cube got cancelled and I'm left with minus 4x by x square minus 1 whole square. Okay, now let t equals to x cubed. We differentiate both sides with respect to x. So we get d by dx here and d by dx here. So dt by dx becomes, here we use the power formula. Derivative of x cube is 3x square. Take the reciprocal on both sides and you get dx by dt is equal to 1 by 3x square. Now using chain rule we get dy by dt equals to dy by dx into dx by dt. So we get dy by dt equals to minus 4x by x square minus 1 whole square into 1 by 3x square. You can see this x and x square got cancelled and I'm left with dy by dt is equal to minus 4 divided by 3x into x square minus 1 whole square, and that completes the result.